In this video, we're going to choose two cubes from a box at random and determine probability of an event. We're going to use 2 yellow cubes and 4 blue cubes for this experiment, but if you don't have some colored blocks around, you can simply write a color on a piece of paper. Just make sure that you're using 6 pieces of paper that are of the same size. And you can write down the colors or use a highlighter. As long as you have 2 colors of the same and 4 colors of the same, you'd be able to simulate the same experiment at home. What we're doing for step 1 is 2 cubes are drawn at random and without replacement from a box containing 2 yellow cubes and 4 blue cubes. We're going to list the sample points for step 2. And since we are only concerned with actually choosing a cube, the order of the colors we choose is not important for this experiment. Here's the diagram that we're going to fill in to describe the colors of cubes that we are choosing. Before we write down all of the combinations of cubes that can be chosen, write down the 2 colors of cubes that you chose. At the end of our experiment, you can see what the probability is of choosing the cubes that you selected. So it's important that you write down your selection before you do anything else with this experiment. For this diagram, we're going to fill in all of the possible choices of choosing 2 cubes. Across the top, since there are 4 blocks, they are assigned block 1, 2, 3, and 4 for blue, and y sub 1, y sub 2 are describing the yellow block 1 and yellow block 2. So if we have these 6 different blocks, is it possible to choose blue block 1 and blue block 1? So that is not possible because there's only one blue block number 1. So I'm going to put an X there showing it's not possible. With that hint, you can probably eliminate a few other combinations as well, such as blue block 2, and choosing another blue block 2. That will not be possible. So any of the duplicates, block 3 for blue paired with block 3 for blue, not possible, and block 4 for blue paired with block 4 for blue. And then of course with the yellow, block 1, and yellow block 2, block 2. So we can eliminate those right off the bat. Now, going across the row, is it possible to pair blue block 1 with blue block 2? That is yes. So block 1 paired with block 2 for blue, that is possible. And then block 1 could be paired with block 3 for blue, and block 1 could be paired with blue 4. And then the blue block 1 could be paired with yellow block 1 and yellow block 2. So far we have 5 different combinations. And then we're going to go to block 2 for blue. Could that be paired with block 1 for blue? Well, notice we already have that combination. And since our concern is with pulling the blocks and not the order of the block, this would be considered a duplicate. And then we go to blue 2 with blue 3. So that is a possibility. And blue 2 with blue 4 is another unique combination. Blue 2 with yellow 1 and blue 2 with yellow 2. So we added 4 more to our list. Block 3 for blue paired with blue 1. Notice we already have that combination written down, so that's going to be a duplicate. Blue 3, blue 2, we already have that combination. So you might notice what's happening here below this diagonal. All of these combinations below are going to be duplicates of what we are writing down above. So I'm going to eliminate all of these duplicates right now so that we can concentrate on only the unique pairings. So block 3 paired with blue 4, blue 3 with yellow 1, and blue 3 with yellow 2 are all unique. And then blue block 4 pairs with yellow 1, blue block 4 pairs with yellow 2. And finally, yellow 1 can be paired with yellow block 2. So if we count these out, we're going to find that we have 15 possible combinations. And what that really tells us is that we could check this number of combinations using our combinations formula. So if we have a total of 6 blocks, regardless of color, and we're choosing 2 blocks, then this is really our combination of choosing 2 blocks out of 6 blocks and using our factorial. 6 times 5 times 4 times 3 times 2 times 1, so there's 6 factorial, divided by 2 factorial times 6 minus 2 factorial. So 6 minus 2 makes 4 factorial, and we can see with reducing, factor of 4, 3, 2, and 1 are reducing, leaving us 6 times 5, which is 30, divided by 2 times 1, which is 2, and here we go, 15 possible combinations if we start with 6 blocks and we're choosing 2 blocks. And that's exactly what we found, but we have all the details of which blocks are paired with which other blocks. So for part 2, we're going to be writing our sample points. So S would be equal to the set of all of these combinations we have listed above. And since we're pairing them up, I'm going to place them in parentheses this time. So I have the pair of blue 1, blue 2, blue 1, blue 3, blue 1, blue 4, blue 1, yellow 1, and blue 1, yellow 2. In the next row, I'm going to pair up starting with block 2 for blue. So blue 2, blue 3, blue 2, blue 4, blue 2, yellow 1, blue 2, yellow 2. My next combination is going to be using blue 3 block. So I'd have blue 3, blue 4, blue 3, yellow 1, and blue 3, yellow 2. Then with my blue 4, yellow 1, blue 4, yellow 2, and finally yellow 1, yellow 2. So we have 15 possible combinations. Those are the sample points for the experiment. For number 3, we're going to assign probabilities to each sample point. Looking at the sample points we just wrote, none of them are duplicating. They're all unique. So they will be assigned exactly the same probability. Since each sample point is unique or equally likely, there's a 1 in 15 chance of being chosen. So a 1 in 15 chance means 1 divided by 15, which is about 0.06 repeating, which is about 0.06. So in part 4, we have 3 different events being described. Event A is that 2 yellow cubes are drawn. Event B, a blue and a yellow cube are drawn, and event C, 2 blue cubes are drawn. So if we go back and look at event A, 2 yellow cubes are drawn. Looking at our sample points, just going to scan across the row and look for 2 yellow, and we don't find 2 yellow until the very last sample point. So 1 sample point out of 15 sample points have 2 yellow cubes drawn. So we set up 1 out of 15, and that's the calculation we just did in the previous step, so we know that would be 0.06 repeating. Next, we're going to look for all the sample points that match event B. A blue cube and a yellow cube are drawn. So the first one, that's 2 blue, blue, here's a blue and yellow, another blue and yellow, there's another blue and yellow. So I'm looking for all sample points with 1 blue and 1 yellow. So here we have 8 out of the 15 events have 1 blue and 1 yellow. So 8 out of 15 is equal to 0.53, repeating. And finally, 2 blue cubes are drawn. So we'd have 1, 2, 3, 4, 5, and 6. 6 out of 15 of these sample points have 2 blue, and that is 0.4. So now look back. What color cubes did you draw? If you had 2 yellow cubes drawn, that means you match the 0.06 probability. If you had one blue and one yellow, then that matches with the 0.53 probability. Or if you had two blue cubes, you had 0.4 probability. So you might ask yourself, which probability is the most likely? And that one is one blue and one yellow, because 0.53 is the larger probability of these three options. The least likely event is A, two yellow cubes, and that's because you had fewer yellow cubes than blue cubes in your sample space.